Hi, welcome to week number 2 of Intro to Engineering this summer. Week number 2 gets into mechanics. Mechanics typically have two parts depending on what area of engineering you're going into. If you're going into mechanical and possibly civil, you'll take both statics and dynamics during your 4-year career. We'll pretty much be focusing mostly on statics. You'll hear the term equilibrium a lot in this particular chapter. Statics deals with forces acting on a body and the body not moving. Dynamics is the body moving with forces acting on it. So dynamics gets a little more difficult because you got to figure out if the body is accelerating or slowing down or how it's actually moving as part of the calculations that you're doing. Those that are interested in electrical engineering, you don't have to take dynamics. But those in mechanical, you will be taking both statics and dynamics. Nobody gets out of statics. So if you are comfortable with trig, then follow what the author does in the book. If you're not, then I suggest you take a close look at the slides, the PowerPoint slides that I put up that are from my AC Circuits class. Essentially, the concept there is to deal with polar and rectangular numbers. So with a mechanics problem, you're going to have the problem statement, and you're going to do your free body diagram. Also an excellent YouTube video that I have posted up there on how to do a free body diagram. Make sure you watch it. So when you have your free body diagram, you're going to sketch in all your forces, and for our statics problem and equilibrium, all the forces in the x, the y, and the z if it's a three-dimensional problem, which again is a little beyond this class, will be equal to 0. So to give you just a little bit more detail about how to do my particular process, I've put together a few pages here that I'm going to show you, and I'll scan these and also put them on Blackboard. So the first part of this concept is simply this. We have an XY plot, and we have a point on the XY plot. How do we identify that point? Essentially, there's two ways that we can do that. One way is we specify an XY coordinate for each one of those. So you notice in this particular case, I have one point A in the first quadrant, and I have one point B in the third quadrant. Right? So the X and Y values for point A are positive 4, positive 5, and the X and Y values for B are negative 8 and negative 3. So you can see here, I've written two equations, A equals 4 plus J5, and B equals minus 8 minus J3. Those are rectangular forms. Rectangular form is simply the X and Y point for the particular value you're putting on the XY plot. So the other way that we could specify those points is with a magnitude and a phase angle. So here's 2 points that I've put on here. One again in the first quadrant and one in the third quadrant. So you notice I've labeled these as newtons because, again, we're dealing with mechanics, so we're dealing with force, and we're going to be dealing pretty much in metric units. So you notice that the first one is 5 newtons at 50 degrees, I forgot what it was, and the second one is 9 newtons at, I've marked it at 220 degrees. This is polar form. Most important thing for polar form, if you want to follow my particular method, is always take your angles reference from the negative 0, or not the negative, the 0 x-axis. So you notice that 40 degrees is specified off of the 180 point, so I added the 40 to the 180 and got the 220 for my magnitude. The key for using my method is if you need to multiply or divide, which we don't do too much in mechanics, but you do a lot in AC circuits, that's where the slides came from, then you want your numbers in polar form. If you're going to add or subtract, which is really what we're going to do a lot of in the mechanics, you want your numbers in rectangular form. To add or subtract, you take your x values and you add them together, or subtract them if you're subtracting, and the y values. You combine the x and the y values separately. The most important part of this process is to figure out how to use your calculator. Right? I can tell you how to use mine, but I can't tell you how to use yours. Again, you probably will find some good tutorials on YouTube on how to do so that you can do this. you can convert between polar and rectangular form. And again, I'll put this up there. The blue ones are the 4 forces, or the 4 points that I showed you, and the red ones are the conversions that I did with my calculator. So, to sum it up, when you get a mechanics problem, you're going to be asked to combine forces. Combine, of course, means to add. So you need to take and put the forces in rectangular form, add the x's, add the y's, you'll get a resultant force. However, most problems ask for the resultant magnitude and phase angle, which means polar form. Hence, you will do your math in rectangular form, you'll put your answer in polar form. Make sure you also take a look at the discussions, because I posted some sample problems that you might see on exam number 1. Thanks, and make sure you post any questions in the discussion forum. Have a good day. Bye.